atomic bomb on the Japanese city of Hiroshima. The bomb was known as Little Boy. 3 days after the Hiroshima blast, the United States dropped the second atomic bomb on the Japanese city of Nagasaki. The bomb was code-named as Fat Man. Fat Man is more efficient than Little Boy. The Hiroshima bomb Little Boy consists of 64 kilograms of enriched uranium to produce 15 kiloton blast. By comparison, Nagasaki bomb, the Fat Man consists of only 6.4 kilograms of plutonium to produce 21 kiloton of blast. Meaning that Fat Man is more efficient than Little Boy. Fat Man was built by the scientists and engineers in the Los Alamos laboratory at the Manhattan Project. During the Manhattan Project, Robert Oppenheimer was the director of the Los Alamos laboratory. He is often known as the father of the atomic bomb. The bomb was 128 inches long and 60 inches in diameter. It weighed approximately 10,300 pounds. Here's the size of a person in comparison. Let's take a closer look inside the Fat Man. Fat Man was powered by a plutonium sphere. The plutonium sphere is similar to the size of a soccer ball. The sphere weighs only 6.4 kilograms. Plutonium is a radioactive metallic element. It was discovered in 1940. Plutonium is considered as a man-made element. Trace elements of plutonium are found in naturally occurring uranium ores. The plutonium sphere is surrounded by explosives. These are the explosives lenses. It is a highly specialized shaped charge. It is composed of 60% of RDX and 40% of TNT. The bomb is equipped with 32 bridge wire detonators, which fitted around the explosive lenses. 24-volt batteries are mounted on one side of the bomb, which is connected to the fusing system. On the early morning of 9 August 1945, the Boeing B-29 Superfortress takes off from Tinian with Fat Man. The bomber's primary target was the city of Kokura. After 7 hours of flight, the aircraft arrived over the target. Due to thick clouds and drifting smoke, they could not able to drop the bomb on Kokura. So, they shifted their target to Nagasaki. Nagasaki was a port city located about 100 miles from Kokura. It was larger, with an approximate population of 263,000 people. At an altitude of about 17,000 feet, the Fat Man was dropped over the city of Nagasaki. 47 seconds later, the Fat Man reached an altitude of about 1,600 feet. The Archie radar antenna emitting and reflecting the signal to the ground. These signals are used to detect the detonation altitude. The radar altimeters were used to reliably detect final altitude. When the altimeters sensed the correct height, then the 32 exploding bridge wire detonators simultaneously releasing electrical sparks. Due to this electrical spark, all of the explosives would go off simultaneously. The thick layer of the metal casing helps to create an implosion shock wave inside the casing. The medium-density aluminum pusher transfers the imploding shock wave. The shock wave then compresses the inner components, passing through a boron plastic shell. Then the shock wave transfers to a natural uranium tamper. And the sphere of plutonium would be compressed. In the middle of plutonium, two elements are called polonium and beryllium. Due to the compression, the two metals mix them together and thereby releasing a burst of neutrons. Approximately 10 milliseconds later, the nuclear chain reaction occurred. One atom of plutonium is hit by a neutron. It splits into two, releasing energy, and it produces two neutrons, each of which goes on to react or split other atoms of plutonium. A chain reaction of atom splittings takes place. This nuclear chain reaction causes a tremendous explosion. The Fat Man exploded at an altitude of about 1,600 feet. The energy from the explosion is distributed over a wider area. If it exploded on the ground, the result of the explosion will be relatively low. The bomb detonated with the same force of 21 kilotons of TNT, forming a mushroom cloud about 60,000 feet tall. Approximately 40,000 people were killed, and destroyed nearly every building within 3 square miles of the epicenter. Inside the epicenter, the thermal heat from the explosion vaporized some people instantly. The damage came from 3 main effects: blast, fire, and radiation. The blast from a nuclear bomb is the result of an X-ray heated air called fireball. The fireball was an extremely hot and highly luminous spherical mass of air and gaseous that sent a shock wave in all directions, initially at a velocity greater than the speed of sound. The firestorm-affected area was roughly 3.2 kilometers from the epicenter. As a result of the explosion, it releasing radiation into the air. There are 3 main types of ionizing radiations. These are alpha, beta, and gamma. The alpha radiation will not do much harm. These particles of ionizing radiation can block by wearing well-protected clothing. Beta radiation is a little more serious. Beta particles are capable of penetrating the skin and causing radiation damage, such as skin burns. Gamma radiation is more dangerous than others, it has so much penetrating power. Gamma rays can pass completely through the human body. It can also result in long-term health effects, such as cancer, cardiovascular disease, and gene mutation. It causes DNA damage in human reproductive cells.